Hey everyone, it's Mrs. Brimlow, and today we're continuing with our exponent rules, discovering the quotient rule. So, if you would like a copy of the notes, they are linked in Canvas, or you can watch the video and you can get a copy later. Okay. So, once again, this is a discovery activity, an investigation. So, similar to what we've done so far with some of our other rules, we're going to do that with this quotient rule. I'm going to get you started with the first example. You're going to try the next two and then see if you can find the connection or pattern that's happening. Okay. All right, so let's go ahead and get started. So, quotient, that word right away should make you think of division. Okay. So, this rule applies to when we're working with examples with division. So, for our first example, we have 2 to the 8th with a fraction bar or divided by 2 to the 3rd. So, I'm going to go ahead and expand that out. So, I'm going to have 8 2's at the top, 6, 8. Okay. And underneath, I'm going to have 3, and I'm going to line them up under the 2's that they can. Okay. Now, let's go take a little trip down memory lane. Okay. We learned back in probably 3rd grade, I believe, that when I divide a number by itself or a term by itself, it just gives me 1. So when I look at this, going set by set, I know 2 divided by 2 is 1, so I can cross that out. That's what it would simplify to. Okay. And then I can do that another time because I have another set of 2's, okay? And then I can do that one more time since I have a total of 3 sets of the number being divided by itself when I'm comparing the number of factors and the numerator and the denominator. So what do I have left? Well, what I have left is 2 times 2 times 2 times 2 times 2 once I've simplified what I could. I have a total number of 5 factors, so I can rewrite that answer as 2 to the 5th. Okay. So once again, you're going to see what is the pattern or how are the exponents in the first column and that last column related. Go ahead and pause the video, try the next 2 examples, see if you can answer that question, and then come back. All right, let's go ahead and finish out these 2 examples. So 3 times 3 times 3 times 3 times 3. And then at the bottom, we have 3. So once again, I'm going to go through and cross out any set that I can simplify where the number is being divided by itself. So in this one, I'm left with 3 times 3. I have 2 factors, so that's 3 to the 2nd power. This last one, I have 5 times 5 times 5 times 5. 6, 7 over 1, 2, 3, 4, 5, 6 fives. Okay. So 1, 2, 3, 4, 5, 6 sets that I can get rid of. I'm just left with 5. Number of factors I have is 1. So we could write this as 5 to the 1st power or 5. Okay. Typically, we would just write it as 5, but I want to write it to the 1st power just so we can look for that connection between our exponents. Okay. So going back to the original expressions, I'm just highlighting these exponents, okay, and then coming to the last column. Oh, whoops, sorry, I highlighted the wrong thing. Don't highlight that. Highlighting the exponent, I apologize. Okay. All right, so what's the connection between these first column exponents and last column? So basically, what can I do to get from 8 and 3 to 5? What can I do quicker than expanding it out to get from 5 and 3 to 2? What can I do to get from 7 and 6 to 1 versus showing all of this work? This is always great to fall back on. It's a great visual, but once again, we're looking for a pattern to make it a little bit easier and to help us with more complex problems. So what you should have found is that the exponents in the last column are the difference of the exponents in the first column. So basically, difference means to subtract. So if I take whatever the top one is, subtract the bottom one from it, I get my new one. So 8 minus 3 is 5. 5 minus 3 is 2. 7 minus 6 is 1. So basically, when we are dividing expressions, exponential expressions with like bases, we keep the base and we subtract the exponents. Okay, so let's go ahead and write that in words. Once again, I'm going to write this all out. Pause the video if you need to get it all down on your paper as well. So when dividing exponential expressions with like bases, keep the base and subtract the exponents. If there are coefficients, divide them. Okay, I'm gonna move this over slightly so you can see everything. There you go. Go ahead and pause the video, write this down if you need to, then come back to finish the notes. All right, make a conjecture by writing your rule with variables. So algebraically, I can explain this rule as x to the power of a divided by x to the power of b is the same as keeping x, that like base, and then subtracting the exponents. Okay. All right, so can you use the rule for this example? M to the sixth divided by n to the third. So going back to our explanation, the first thing we need to focus on are our bases. Are they the same? If they are, we use the rule. If they're not, we can't. So the base in the numerator is m. The base in the denominator is n. Those are not the same, therefore you cannot use the rule. So no, because the bases are different. Okay. So the rule wouldn't apply to this example. Right? All right, let's do a few practice problems together. And then you can either go ahead and practice or what's on Canvas or see me for practice in person. So I want to remind you of this think bubble. When in doubt, expand it out. There is nothing wrong with showing your work. I always encourage you to do that. Okay. So for the first problem, the base is 3. A lot of people want to divide the threes because that's what we've been taught to do. But because we're working with exponential expressions, so expressions that have exponents, we don't do that. The rule says to keep the base in this case, which is 3, and then subtract my exponent. 7 minus 2 is 5. So you do not want to divide those bases. You want to keep the base, subtract the exponents. Okay. In this next example, 10 minus 7 is 3, and the base is m. So that's m to the third. Okay. Once again, 4 is the base, so keep the 4, subtract your exponent. So 23 minus 20 is 3. And last but not least, d is our like base. 8 minus 7 is 1, or you can just write it as d. I'd like to add three more examples to these notes quickly while we are working on them. So example E, I'm going to do x to the third over x to the seventh. Okay. So x over x is just x. That's our base. 3 minus 7. So you're going to notice that exponent at the top is smaller than the bottom. So we're going to need to use our integer rules. We're still subtracting. That doesn't change. 3 minus 7 gives me negative 4. You can have negative exponents. We are going to learn how to make them positive later in the unit. For right now, you can leave it negative if you end up with a negative answer. Okay? Another example I'd like to do with you is this. So I like to break these up, put a little multiplication sign or even a line to divide them and go piece by piece. So at the beginning, we have coefficients. Those are numbers that are attached to variables, or in this case, bases. Okay. They are treated like the problem. So the problem is division, so that's what I need to do. So I do 8 divided by 4, which is 2. Okay. Now I'm going to move on to my bases. So, and use my rule. My like base is x. 8 minus 3 is 5. Okay. So when you have coefficients, apply whatever operation you're working with, in this case, division. Okay. All right, one more example I'd like to do with you. Okay. So I have coefficients and then I have several variables I'm working with. Once again, I like to break it up, draw my lines and then go piece by piece. So we know that this is division. If I do 14 divided by 21, it's not going to give me a whole number. It's going to give me a decimal. I can't do 14 divided by 21 evenly. Okay. If that happens, you just need to simplify the fraction. All fractions are division problems, and I'd like you to leave it as a fraction. So just simplify. So the greatest common factor, or the biggest number that is divisible by 14 and 21, is 7. So 14 divided by 7 is 2, and 21 divided by 7 is 3. So I can simplify 14 over 21 to be 2/3. Okay? Then I'm going to work on x. So when I look at x, that's my like base. Now I have x to the second at the top. At the bottom, I don't see an exponent, but there has to be one there if x is there. The exponent here would be 1. Once again, we don't typically write it that way formally in math, but if you need to add that in for yourself, I encourage you to do that. 2 minus 1 is 1, so you can either add the 1 or leave it as just x. Okay? And then I'm going to deal with y. So 7 minus 4 is 3. So that would be it. So when you have multiple parts to a problem, especially these division problems, break it apart, go one part at a time. Okay. So if you have any questions, let me know. Make sure if you're out, you get a copy of these notes when you return. And if you have any questions, let me know. I will chat with you soon.